Assalamualaikum warahmatullahi wabarakatuh. My name is ABDUL HANIF bin Milo. Today, me and my group member Ahmad Firdaus and Muhammad FAJRUL HAIQAL want to present about remote sensing for a site-specific crop management. We move to the first slide, which is the introduction. What is remote sensing? Remote sensing is a tool in agriculture that involves gathering information about crops and their environment without direct physically contacts. It's released on sensor and instrument that capture and record the electromagnetic radiation emitted or reflected by a surface. It's also used to collect data about crop and their surrounding environment, such as soil moisture, vegetation health, and yield potential. The process begins with the deployment of sensor, which could be mounted on satellites, airplanes, drone, or ground-based device. This sensor captures the environmagnetic radiation and convert it into digital data. The information obtained through remote sensing help in making informed decisions and understanding change occurring in the environment over time. Next slide is the technique of remote sensing. First, we have UAV, which is unmanned aerial vehicle, or we call it drone. It can be equipped with a variety of sensors such as cameras and thermal imaging system. It's also used to collect high-resolution image and data about crop at very local level. Second, we have satellite imagery. This involves collecting data about the Earth's surface from satellite orbiting the planet, used to monitor crop growth, map irrigation system, and assess crop damage caused by natural disaster. Third, we have aerial photography. This involves taking photograph of the Earth's surface from an airplane or helicopter. It's used to identify crop stress, map soil types, and monitor change in land use. Aerial photography delivers high-resolution image. Next slide is benefit of remote sensing. First, optimize input management. Accurately calculate water, fertilizer, and insecticide to specific area. Monitor crop health and growth for treatment areas. Second, disease and pest management. Monitor crop health indicator. Also reduce crop loss and pesticide use. Third, improve resource efficiency. Can save water, fertilizer, pesticide by reducing waste and environmental impact. Also increase resource efficiency and lower price. Fourth, enhance profitability. Crop management profitability boost by data device decision. Maximize crop productivity and minimize input costs. Also prevent crop loss. 5. Data prevent decision making. Provide precious cross and field data. Offer real-time crop health, growth, and environmental data. Aids in irrigation, fertilization, pest control, and management practice. And the last is reduce yield variability. Crop performance analysis and detect yield variability element, soil fertility, drainage, pest variability, and use information for site-specific management.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FAJRUL bin Azman, and in this video I will present about monitoring and mapping crop variables. What is monitoring and mapping of crop variables? It refers to the process of collecting georeference data on crop yield, characteristics, and other factors such as moisture content, soil quality, and weather patterns. Remote sensing can monitor and map various crop variables, providing valuable insight into crop health, nutrient deficiency, and irrigation needs. Remote sensing can monitor, and map several specific crop variables, including vegetation indicator index like the normalized difference vegetation index, and DVI assess crop health, and vigor by measuring reflected visible near infrared light. Soil measure, remote sensing estimate soil moisture levels, aiding in irrigation management and drought assessment. And lastly, crop stress by detecting changes in leaf reflexes. Remote sensing identify crop stress from water shortage, nutrient deficiency, or pests, and enabling early intervention. And now we go to the monitoring and mapping of crop variables. These variables offer valuable strategies, insight into crop health, nutrient deficiency, and irrigation needs, enabling targeted management strategies. Farmers can implement precise irrigation, fertilization, and pest control, and enhancing resource efficiency and crop yields. And then early warning system. Remote sensing data helps develop early warning system for crop health issues, allowing timely intervention to reduce risk and losses. And then water productivity, monitoring soil moisture and crop efficiency, improve water productivity by enabling efficient irrigation management. In conclusion, remote sensing technologies provide a powerful means to monitor and map various crop variables, allowing for informed decision making in agriculture and enabling targeted management strategies to enhance crop health, nutrient management, and irrigation process. And now I will talk about the connection between remote sensing and precision agriculture. For the past decade, precision crop management systems have been integrated with remote sensing technologies to enhance data gathering, processing, and interpretation from ground-based, aerial, and satellite observation. Remote sensing technology, which include high-resolution satellite data equipped with multispectral and hyperspectral sensors, can generate large volumes of data rapidly and affordably. How remote sensing data can be integrated with precision agriculture technology? Variable rate application (VRA) in precision agriculture is a technical field dedicated to the automated application of material across specific landscape. The VRA technology system make decisions and adjust inputs such as fertilizer, pesticide, and irrigation according to the distinct needs of different zones within the field. Application of RS in precision agriculture is optimized resource management, environmental sustainability, and site-specific farming practices.
Alright, for case study on paddy, we can conclude a yield estimation. Remote sensing imagery is used to estimate the rice yield, aiding farmers and policymakers in making informed decisions on efficient land management. Next is mapping rice paddy distribution. Remote sensing data will identify the crop areas and their stage, providing information on crop mortality. And next, it can monitoring a crop condition. 8 different remote sensing tools and techniques are utilized to monitor the overall health and growth condition of paddy crops. Alright, next for the case study on wheat on yield estimation, a study published in Frontiers in Plant Science explore the use of remote sensing data and machine learning to approach for estimating wheat yields. And next for the crop yield monitoring, research from NASA technically remote sensing data for monitoring crop yields, including winter wheat using a cost resolution data. Alright, so for the challenge, first is cost. It's expensive image data, need for special software and expertise. And also the data. A huge amount of the data stored and processed combining data from different sources is tricky. And next is interpretation. Some data isn't detailed enough for small change in field. Next is infrastructure. It's a rural areas might not have a good internet. Storing and sharing big data can be difficult. Alright, for the future direction, it's hyperspectral imaging. So it can let farmers spot problem early, even before light can see them. Tell different plants apart like weeds from crops. Guess how much they harvest and how good it will be. And next is AI or artificial intelligence. It helps farmers to analyze data automatically, saving their times. And next is putting them together, so farmers can use resources like the water and fertilizer exactly where they're needed, not wasting any, keep their crop healthy. Example, catching disease before they spread, spraying only the weeds, not the crop, watering each part of the field just the right amount, and knowing how much food they get even before it's grown. Alright, next for the slide. In conclusion, remote sensing technology provides farmers with precise, timely, and detailed crop information, facilitating data-driven decision making. This technology helps optimize input, reduce yield variability, and enhance disease and pest management. Consequently, farmers can boost profitability, minimize economic risk, and reduce the environmental impact of their crop management practice. So that's all from us. Thank you very much. Assalamualaikum.